Okay, let us continue with our review for our minor summative assessment covering determining if a function is increasing or decreasing, whether it has relative extrema using the first derivative test, as well as the possible points of inflection, where those points of inflection occur, and my concavity. Okay, as well as linear approximations. So quite a bit of things for this particular problem, number 3 here. Okay, so how are we going to work through this? Well, we want to find each of these items, so let's just work slowly through. We know we're going to need f prime of x. F prime of x is going to be equal to 6x squared minus 48x. All right, so our derivative using the power rule. And we know we need our second derivative. And our second derivative is going to be 12x minus 48. Okay, now factoring can help us be able to find roots more easily. So if we factor this first one, if I factor out a 6x, that is going to give me 6x times x minus 8. And for the second derivative, if I factor, that's going to be 12 times x minus 4. So what does that tell me? That tells me that my critical numbers, right, are going to be if f prime is equal to 0 or f prime does not exist. With a polynomial, f prime is always defined, so we know that our solution, right, therefore, or our critical numbers, therefore, are going to be at x equals 0 and at x equals 8. All right, so that's going to be where if I'm going to have maximums and minimums, they will occur at x equals 0 and at x equals 8 for our function. Where is my function increasing or decreasing? Well, let's do a quick sign analysis and recognize that we really don't need to do the sign analysis if we understand that we have a cubic function that is increasing there, right? And we actually know that this x value is going to be an x value of 0, and the x value over here is going to be an x value of 8. All right, but let's go ahead and do our sign analysis. That if x is 0, if x is 8, and we want to figure out f prime, we're 0, we're 0. Multiplicity is 1 for each of them. So let's say that x was negative. If x was negative, 6 times x would be negative, and negative 1 minus 8 would be negative, so I'd be positive, right? Which makes sense. F of x is increasing, then decreasing, then increasing, which tells me that I am increasing, right, that f is increasing if f prime is greater than 0. So that's going to be if x is less than 0 or x is greater than 8. And we know that f is decreasing if f prime is less than 0. So therefore, if x is between 0 and 8. Right? We know that we have a maximum if f prime changes from positive to negative. So therefore, at x equals 0. And we know we have a minimum if f prime changes from negative to positive. So therefore, at x is equal to 8. Now, what is that max value? Well, for f of x, if x is 0, that's going to be y coordinate 5. And if x is 8, right, then f of 8 will be my max, or excuse me, my minimum value. Now, what does f of 8 equal? F of 8 is going to be 2 times 8 to the third power minus 24 times 8 squared plus 5, which will be some negative number. Okay, now, what about the possible points of inflection, right? We know the possible points of inflection are going to come if our second derivative is equal to 0 or our second derivative does not exist. Well, for our situation here, that's going to be at x is equal to 4 because we have seen what our second derivative is. Then where am I concave up or concave down? I can do a sign analysis for this as well. So sign analysis, if x is 4, what is my second derivative? The second derivative is 0. If I'm a number to the left of 4, for example 3, my second derivative is negative. If I'm to the right of 4, my second derivative is positive. And notice that I'm concave down there and concave up there, and I have my point of inflection where that concavity changes. So f double prime is greater than 0. I'm going to be concave up, right? And that's going to be if x is greater than 4. F double prime less than 0, I'm going to be concave down, and that's going to be if x is less than 4. And my point of inflection, we already talked about my point of inflection has to have a change of sign. So if f double prime changes sign, so therefore at x equals 4, f double prime changes sign, and that's going to be the point for f of 4. Where of course f of 4 is going to be equal to 2 times 4 cubed minus 24 times 4 squared plus 5. And if you don't have a calculator, we're not going to be expecting you to do that without a calculator. And if you do have a calculator, then yes, we will expect you to do that. Then our last problem for our review, function f of x is differentiable, and we're given f prime. We want to find the following. We want to write the equation of the tangent line at this point. So we know a point, we need a slope. And the slope is going to come from f prime of 2, and f prime of 2 is going to be negative 4 times 8, so that's going to be negative 32. So our equation, y minus y1 is equal to m times x minus x1, but it can help us if we know we're going to be doing linear approximations to say y equals y1 plus m times x minus x1. So therefore our tangent line is going to be y equals negative 14 minus 32, because that's our slope, and then x minus 2. All right. Now, estimate the value of f of 1.9. Well, our linear approximation, f of 1.9, is going to be approximately negative 14 minus 32 times 1.9 minus 2, which is negative 14 minus 32 times negative 0.1, which is going to be negative 14 plus, right, this negative times that negative, plus 3.2. So that is our approximation, negative 14 plus 3.2, right? And if we actually wanted to do that mathematics, we would be able to say that that's like negative 11 plus 0.2, or in other words, negative 10.8. There's our approximation. So is this approximation, is this estimation greater than or less than the actual value? Justify our answer. Justification can help by thinking about it first. And we know that if we are concave up, it doesn't matter how we are concave up. As long as we are concave up, our tangent line is going to be below our graph. If, on the other hand, we are concave down, and it doesn't matter how we are concave down, if we are concave down, our tangent line is going to be above our graph. Well, how do we determine concavity? We need to find the second derivative. What's our second derivative? Our second derivative is going to be the derivative of the first. So that's going to be negative 12x squared. All right. Now, what is that second derivative at our point where we have our tangent? So what is that second derivative at 2? That second derivative is negative, and that's really all we care about. So therefore, we know that we are concave down. And if we are concave down, that implies that the approximation is greater than the true value. All right, so is our estimation greater than or less than? Our estimation is greater than the actual value. And be careful how these questions get asked. We could be asked about the actual value. If we're concave down, we know that the true value is less than the estimated value. So be careful on what's being asked. Make sure you're practicing. Make sure you're asking questions. That's what we've got. Linear approximations, concavity, tangent lines, increasing, decreasing, points of inflection, lots of things, lots of practice. You'll get better. We just want to see where you are right now. Thank you for your time.